This is the third week, and you will have to read chapters in 5 and 6, and again complete the worksheets for those chapters. After you've completed the worksheets, then you can take the practical test. And I'm also expecting for this week that you will do the first 3 steps of your research project. Chapter 5 focuses on the nuts and bolts of how to postulate a relationship between variables in the form of a hypothesis. A hypothesis has to be empirically testable, stated in a specific relationship between a dependent and independent variable, and is derived from theory. The relationship between hypotheses can be either positive or negative. A positive relationship is where the dependent and independent vary in the same direction. In other words, as one variable goes up, the other goes up. In contrast, a negative relationship is where variables vary in opposite directions. As one goes up, the other goes down. But remember this, we only use ordinal or higher variables, interval or ordinal, when we're stating a directional hypothesis, which positive and negative hypotheses are. Where at least one variable is nominal, then we cannot state a directional hypothesis. The hypothesis in this case must specify the type of relationship between the variables and how differences in the different and the dependent are linked with differences in the independent. When it comes to writing a hypothesis for one or more nominal variables, go to page 92 and refer to figure 5.2 in your text. As we have said in chapter 4, we don't actually prove anything. What we actually test for is the null hypothesis rather than the hypothesis. A null hypothesis postulates that there is no relationship between the independent and dependent variables. Consequently, the question we want to answer is whether we reject or fail to reject the null hypothesis. If we fail to reject the null hypothesis, then we're concluding that there is no relationship between the two variables. If we reject the null hypothesis, then we are deciding that a relationship does exist between the two variables. In chapter 6, we're looking at sampling and sampling error. The test explains different types of sampling methods. A haphazard sample is one based on convenience or self-selection. A good example of a haphazard survey are street corner interviews, where people who happen to be passing by are interviewed by a pollster. Passerbys could be also considered self-selected because they can choose whether to stop and answer the questions or just merely pass on by. Another method is quota sampling. In a quota sampling, a researcher sets numerical targets for groups of people based on their proportional representation within the population. The best form of sampling, however, is probability sampling, where each person in the population has an equal chance of being selected in the sample. How many people you need for a probability sample depend on how much accuracy you need in the results, how much confidence you want that the results are within a specified range of accuracy, and how much variability there is in the variable. Accuracy is also referred to as the margin of error. The degree of accuracy is usually stated in plus or minus percentages. For example, if a survey has plus or minus 3% margin of error, and the results of the survey show that candidate A is supported by 52% of the voters, as opposed to candidate B, who's supported by 48%, then the true percentage for candidate A is 49 to 55%, plus or minus 3%, while candidate B true percentage is 45 to 51%. Since our sample is based on probability, we cannot be sure that the results are within the level of accuracy we have specified, and for this reason, this is why we must specify confidence level that the results are within the level of accuracy. Confidence level is stated in probability terms. For example, a confidence level of 0.01 means that there is one chance out of 100 that the results of a survey lie outside the accuracy range. A confidence level of 0.05 means there are 5 chances out of 10 the results are within the range. Consequently, when we say that a survey has a margin of error of plus or minus 3%, or whatever the percentage is, and a confidence level of 0.05%, then we are saying that there are 5 chances out of 100 that our results fall outside of our range of accuracy. In other words, more than our 3% margin of error. The last important factor in determining a sample size is variability. What we need to remember is the greater the variability within a variable, the lower the survey accuracy. However, when the opposite is true, then the results are more accurate. When computing a sample size, a researcher needs to take into consideration how much variation is involved. For random sampling, where everyone has an equal chance of being selected for the survey or the study, requires that there is a list of the entire population that is being studied.